Hey everybody, so it's time for another weekly update. It's been a pretty busy week, trying to get lots of things out because I'm actually going to be gone all the next week on some international travel. So it's for work. I'm actually going to be going and doing some teaching and some programming work, but I will be out of the country. So next week's video will have what little video I get from that. You know, a lot of people say it's neat that you get to go to all these places, but really a lot of the time I spend most of my time in a conference room or in a lab and don't get to explore that much, especially because right now we're so busy with the end of the financial year coming up. All the government agencies are trying to get projects finished up, so it's actually a really crazy busy time. Probably be pulling some pretty long hours until the end of October. You know, as I record this, so it's Saturday afternoon, and Jay Pearson has said this before of Pearson Work Holding, that when you go past the business parks on the weekend, it's always the owners that are there. I mean, you know, being a small business owner doesn't mean that you're working less. It very frequently means you're working more. And that's certainly what I expected and something that I've been fine with. But before I go on too long, I want to just go ahead and go out to the shop, show you some of the things that I've been dealing with this week, and talk a little bit about work quality. So let's go to the shop. So this doesn't look like much, but this is a different server than was in here the last time that we walked through. I've got it up and running. It's actually got a whole 256 gigabytes of RAM and two 1 terabyte SSDs that I got in this week and built it as a RAID 1 array. So this is going to be running my inventory system, and I'm thinking about switching my content management from OneNote and Microsoft Cloud Sync over to running an Atlassian tool or more of a wiki type tool in-house and then backing it up to the cloud. I don't necessarily care so much about the in-house other than it's cheaper and I already have the hardware running. But as potentially there's more growth in the future, I want to document processes for others or myself, get some more process reliability in there. And really I think it would be good to have that done in such a way that I don't have to have somebody have access to a OneNote notebook through Microsoft that has unknown simultaneous editing and syncing capabilities. Also, my OneNote's just getting really messy, so maybe sometime we'll do a screencast and look at that. Right now, the inventory system is running on this little Raspberry Pi, and it's working great, but it is a pain to get some of the packages compiled on the Raspberry Pi and running, since it's an ARM processor instead of like an Intel or an AMD. So I'm probably going to go ahead and, just for ease, go ahead and run it on the server since I already have it sitting here churning away and pumping out heat anyway. So that migration is going to be in process over the next week. I can get in remotely and do all of this. I've been spending a lot of time in here, which is part of the mess, building up some circuit boards. So you can sort of see one right there with some solder paste left on it, and a little prototype there on the bench, and another stack over there on the left corner. So spent probably a day and a half in here building up those and getting them tested and shipped out to my customer before I leave. And down here on the end of the bench, you can see these are some of the inventory tracking labels. So I'm printing these myself, and basically I've given up on trying to have a schema-based inventory system, meaning, you know, R stands for resistor, and then the value, and then the size, or something like that to build a part number. I'm just using sequential numbers, 1- being electronics components, 2- being mechanical components, 3- PCBs. So there are a few broad categories. I'm going to try to keep that under, say, half a dozen categories. And then everything just gets numbered sequentially. That makes it really easy in these kind of bins to just look at my bill of materials and say, you know, okay, I need part numbers 6, 13, 18, 112, and 300. And I just go to the bins, which right now have between 50 and 100 in them, go through, find that bag. I can scan the barcode, say how many I used, and we're done. It also makes building my orders a lot easier, and that's something that I'm increasing the functionality for all the time, as I've got time in the evenings to sometimes work on that inventory system. So I'll also be showing you that and how I'm using a Raspberry Pi with a touchscreen as my end user interface, since it's just a web application. Now you'll notice the forklift is gone, so it's finally getting repaired. While I'm gone, because we're going to be moving in some new heavy equipment over the next couple weeks. So stay tuned for some of those updates, but I don't want to give too much away there. Okay, so the last thing that I wanted to show you that I've struggled with quite a bit this week has been some of these parts. So these are for a prototype for a customer. They're potentially going to want to order lots of these, and so I need to have some design for manufacturability in mind, because we're going to potentially be making a lot of these things. And of course, it's a lot more complicated than this. These are just some of the sub pieces. And you see there's a lot of material that's removed in these. So I did one out of aluminum and one out of ABS plastic, just to see what would perform well for this application. The ABS is a little bit lighter, but unfortunately it's not going to hold up to sun as well as we need it to. So we'll probably be going with aluminum and trying to reduce the weight even more. But anyway, so I thought, well, there's a lot of material to remove, so I'm going to have these water jet cut, and then we'll just do final finishing ops on the mill and we're done. And I would be doing this with another company's machine that's nearby, because these are a little bit too big for my machine. Unfortunately, so the ABS, it looks pretty good. There's a little bit of taper to it, as you can see. The top is sticking further out to the left. I mean, all water jets have a taper, but I've definitely seen thicker material cut with not much taper. On the back side of the aluminum, you can see there's some real nasty places here. And on the top side, where the lead in and lead out was, I don't know if that just wasn't well programmed or what, but it's pretty bad. Also, there are some inconsistencies between these two parts, which there shouldn't be. So this hole and this hole should be the same size. And they're definitely not. So I don't know if that was a materials difference or what was going on there. So overall, they just didn't work out that well. Sorry, I'm still trying to get used to driving this stabilization gimbal, so try not to make you too seasick. So unfortunately, that's just not going to work. I think we're going to mill it all just from a sheet. And I was also really surprised when I got the material back that instead of starting in a corner, all these parts were taken out of the dead center of my raw sheets. So I was just really frustrated by this. I know it's easy to get busy. I mean, I'm certainly very, very busy right now. But one thing that I pride myself on is the work that I produce is part of me, and I want to guarantee to my customer that they're always going to be happy with that. And if there is a mistake, I'm going to own that mistake, and then we're going to do our best to fix it. This was, in the end, a waste of my raw material and a waste of about $130 in cutting fees. I was just really disappointed in the end results. And I don't know if that's so much a function of the water jet. Maybe this particular water jet, I think they were older, makes it a little more difficult to do. And I know water jets aren't generally a finishing option. Generally, you use them as a first op and then go back and clean things up. But in the end, I don't think it's worth it if that's what the cost is going to be, because there's so much cleanup to do, and I have to be so much more careful about probing in the material. On these little adapter pieces, you can see there's large cuts into the piece by the jet and tabs that are left on. There's a lot of backlash in the machine, it looks like. So overall, I just really wasn't that thrilled. I don't want to dump on this particular organization. Just used it as a talking point to say, I see why customers get frustrated sometimes, and this is an experience that I don't ever want my customers to have. I always want them to be thrilled when they open the box and get their products out. So that's why I try to give the best results I can for them. In the same project, I've also been working on some pieces with captive hardware. So if you don't know, captive hardware just means the screw is retained, it doesn't fall out. But you see, it just fell out. And so this is from McMaster-Carr. There's the screw and a fastener that's supposed to hold it in. It's really just too loose. I think it's designed more for thin sheet metal panels that probably don't have the amounts of vibration I think this is going to encounter in travel. So I tried using some of these little snap rings, thinking that I might be able to use them on the necked down part of the screw. If we can get this to focus, yeah, up there right towards the bottom of the head. But unfortunately I can't get them to expand enough to get over the threads without breaking. So I think in the end, I'm just going to end up making a custom screw for this. So I'll probably end up threading the part here and then having the screw through it, and then a necked down section that will retain it in there. A little bit hard to describe, but I'll show you what it looks like as soon as I get a few of those made and prototyped. And then these just, I need to do some minor redesign. There were a couple things on here that don't work because of how I designed it. There are also some things that didn't work because of just the cutting process. So much of this got way oversized or significantly tapered. So I'm going to do some redesign, and we're going to go with metal. We can remove more material out of the metal and have the same strength as versus plastic. With plastic, to get the same strength, we need more material. We can't remove as much. So I think I'm going to try to trim this out a little bit more, and then we'll just have some machined from scratch and go that way. So that's most of the things I've been working on this week. The rest of the week was spent doing a lot of software. So you may or may not know about LabVIEW. It's a pretty common measurement and acquisition programming language that's used in a lot of scientific and engineering laboratories. So I'm a certified LabVIEW developer, and I have been not doing so much LabVIEW recently, but now I've got several projects that need it. So I spent some time this week sitting here writing a lot of LabVIEW code so that I could get the hardware running, so that I could test it and tweak the hardware more. And that was a little frustrating, really, because I know I'm going to be gone for a week, and here I am sitting here doing things on a computer that I could do anywhere. But again, that's just how it goes sometimes. So I needed to get that done so I could test hardware, and that's just how it was. So really a lot did happen this week, and I'm here, as I said, on a Saturday. I'm just picking up, cleaning up, taking all the trashes out, getting boxes to recycle, tidying up. Building circuit boards generally results in a nest around me of empty parts bags and empty parts tapes and bad parts and things like that. So there's a lot of cleanup to do. And that'll be for another hour or two this afternoon. And I'll go home and pack my bags and get ready to take off. So I'll see you next week, and we'll have some footage from Trinidad and Tobago. Bye.